Hello. A very good morning to all of you. So today we have a very special meeting. One of our esteemed alumnus of our 1988 civil engineering batch, who has done BTech from our college as well as MTech from our college, very closely associated with our college. And for many years, he has been an inspiring person in the field of geotechnical area, even though he has done his structural engineering masters. Well experienced guy. So we are indeed really happy and proud to have Mr. Reji John with us. I am pretty sure that all the alumni as well as all the students of civil engineering will benefit from this extremely useful talk by Mr. Reji John. And also this is just a start from him, and we'll have more collaborations with his firm, Bor Specialties Bow, in future also. So it is really a wonderful moment for global alumni as well as the civil engineering department to have such a wonderful personality with us. So let me formally invite the head of the Department of Civil Engineering, Dr. Bindu, to formally invite Mr. Reji John. So, teacher, please.
Thank you, Sudhir. A very good morning to all of you. So today we have Mr. Reji John, an alumnus of our college with us. So with immense pleasure, I will introduce Mr. Reji John to the audience. He's an alumnus of our institute. He did his BTech and MTech from our college. And he has a Master of Business Administration in Finance from University of Leicester, UK. He has extensive design and build experience in ground engineering, ground improvement techniques, deep foundations, shoring walls, temporary and permanent retaining walls, specifically in diaphragm walling and secant piling. And in addition to it, he has design and build experience in near-shore marine structures, specifically gravity block walls, sheet pile walls, diaphragm, and also and is currently working as director in Specialties Bower, UAE, a German multinational ground engineering company. So with immense pleasure, I welcome Mr. Reji John to this meeting. And please, sir, invite sir to the dais.
Thank you, Dr. Bindu. Good morning, everybody. Actually, it's a privilege to stand in before you in my college. I still remember the days I spent here during my undergraduate course and my master's course, especially in my undergraduate course where I didn't bother to study much. And in my master's course, which I had to study a lot under my professors, esteemed professors, UC Ahmed Gutti and Narajan sir. respected professors, my dear students, and the faculties, and the people who have joined from various parts of the globe. This is the first time I'm speaking in a university or a college. I've done seminars. Okay, I've done a couple of seminars in IIT, but only for professionals, nothing to do with the faculty or the professors. So I'm a bit tense now because I'm standing in front of the professors who have experience in design and probably in a lot of projects as well. Let me talk a little bit about myself. I did my engineering and I moved to UAE in 1992 after my post-graduation. I started working in a structural engineering company for 6 months, after which I moved to geotechnical company. I was a design engineer. I did my design from 1992 to 1996, after which I've moved up to the detailed technical analyst, then to management role. I did my MBA when I was working there, and I did my MBA in finance, which has nothing to do with engineering. At the moment, I'm working as a director for BAO, specialty BAO in UAE. Since the last 30 years, I'm almost in UAE. I've experienced in different types of fields, as Dr. Bindu mentioned. Today, I'm going to talk a little bit about the basics of soil improvement. Soil improvement, if you look, it's an ocean. I have not seen a lot of techniques and design importance given to soil improvement in this part of the world. Although we have a branch in Delhi, we have a back office of about 2,000 people in India who are doing a lot of works in ground engineering, serving different parts of the world, but not for many projects in India. I have seen different types of techniques. And when I talk about BAO, we have 3 divisions. One is the specialty BAO, which means specialized construction. BAO means construction in German. And where we do the contracting business, design and build BAOs. And we have another division, building machines for all type of drilling works, grouting works, pumps, cranes. These are the type of works the machine division do. And we have one more division doing the environmental projects, which includes water retentions, water explorations, water purifications, dam surveys, and all those things. I basically represent the construction division, which is called Specialty BAO. That's all about me and my company. Let's directly go into the presentation. Why do we do soil improvement? I just found a simple sketch, simple picture from, I don't know, from where I got this. Basically, this is ground improvement. You can see on his left leg stamped in the soil where it is not stable enough, whereas the right leg is on top of an improved soil, I would say, with a mesh being put on top of the soil. Basically, the soil improvement means improvement of the soil by increasing the bearing capacity through the improvement of the friction angle and the Young's modulus. That's it, basically. Improving the friction angle and the Young's modulus. Basically, improving the stiffness of the soil. Look, let me tell you in advance, I'm not a design man. I did designs probably about 25 years back. I oversee the design sometimes. But if you ask, you have a Q&A session afterwards. If you ask too many questions on the designs, I might not be able to answer, but I will give answers after a while talking to my technical manager. So improvement of soil is basically improvement of friction angle and Young's modulus. And you do different solutions based on the soil, based on the analysis. You do different designs and different methods to improve the soil. At the end of the day, improving soil is to increase the sustainability of the earth. That's what it is. Why soil improvements? Like this is a picture of a school building in the UK, where they built the school building with the deep foundation piles, and they ignored the playground. Left side of the picture, you can see the time when it was built, and the right side, you can see after 5 years, they have seen that the ground in front have settled. It is either consolidation or liquefaction or whatever it is settled. Basically, it was not designed. The playground is not designed, was not designed. Often we ignore these things while we design our structures, basically due to cost constraints. But at the end of the day, if you try to save pennies when you do a proper design, you will spend a lot of money at the end. This is what we see in a lot of projects around the globe. I have traveled in excess of 50 countries, and I've done seminars in many places. We might think that it is improved in certain parts of the world, but most of the places, at the end of the day, everybody goes behind the penny, basically the money, which in turn increase the cost at the end of the day. I have one question. I hope everybody understands English here, and if I include Malayalam in between, you have no issues, right? I hope it is good. Okay, where we use soil improvement. Basically, soil improvement is basically done in shallow structures, for shallow structures like oil and gas projects when you don't have multi-story buildings there, reclamation projects, which is definitely where you definitely need consolidation, compaction, and improvement. Warehouses, which are not multi-story buildings, the bearing capacity requirement is lower than the high-rise structures. Container terminals, where you need to have containers put on grounds where the soil might be weak. Airports, definitely. In Dubai, Abu Dhabi Airport, I'll come to that at a later stage. Then general improvement structures, where you might not need anything, but you need to improve the soil because of settlement and bulkage. Soil foundation, why and what and where. On the left side picture, you can see the tank there. The tank has been designed as like the what do you call, the school building we have seen. Tank is perfectly designed for many things, which include liquefaction, which include the bearing, pressure, the horizontal loads, everything. At the end of the day, the tank will be perfectly safe, but outside the tank, you don't see much improvement, and you can see out just below that absolute settlements there. The middle picture says you can see the cracks on the roads and settlements. This is basically called liquefaction. I believe the students know what is liquefaction. Basically, liquefaction means, in a nutshell, if I say that, the soil behaving like a liquid. Soil will flow. If the soil is not stiff enough, the soil is not improved, it will flow like water, like liquids. So the liquefaction has to be mitigated, and the potential has to be identified and treated properly. On the right side, this is the famous building, the Pisa Tower. You can see different settlement. I've been to this place and I've seen it looks exactly like this. When you stay, you are always scared to go near to this building, although people go very near and inside that. It's because of the differential settlements. This has to be identified and analyzed and designed prior to execution of a structure. When you look into the ground improvement, piling always could be a ground improvement activity. Piling also is improving ground to take the bearing capacity of bearing loads of the loads and improving the bearing capacity, but that is not good enough. When you look into that left below picture, you can see a building. The piling is perfect, but the soil was not improved, and because of the negative skin friction, some portion of the pile has settled, which caused an overturning moment and basically structure fails. The right side picture also, which explains about the negative skin friction due to no soil improvement there. So when you say piling is not always enough. This can be mitigated in another way by increasing the load bearing capacity of the pile, considering the skin friction as well, negative skin friction as well. Just before, I forgot to tell you, if you want to ask any questions at the end of the day, end of the seminar, you can note this slide. I don't know whether you can see the slide number. Slide number you can see there. Yes. Note these slides, and then you can come back to the slide number, and then I can go and clarify the questions if needed. Let us talk to the methods of improvement. Basically, there are three methods. It all depends on the soil. Soil improvement is basically either consolidation or compaction or reinforcement of the soil. At the end of the day, all these three techniques are going to increase the Young's modulus, basically the stiffness and the angle of internal friction of the soil. So let us look into the consolidation. I will go detail into these things and the techniques in the later slides, but let us go into the summary of the consolidation. I believe the S7 and the S8 students at least know what is consolidations. And, are there any first years here? Any S7, S8 students? Okay. The consolidation is basically, it could be by itself, by the self weight or surcharge or induced consolidation. Basically, the soil by its own weight settles down. That's called consolidation. You can put surcharge and give artificial consolidation or natural as well. Then the compaction. Compaction can be either surface compaction or deep compaction. I will go detail into this in my latest slides. Basically, all these things are based on the type of soil we are interfering with. This compaction is done using what you call the rollers, vibrators, hammers. It depends on the type of compaction, what you choose based on the soil. Then the third one is the most important thing. It's the reinforcement of the soil. Piling is one type of reinforcement. But the reinforcement of soil is done when the soil present cannot be compacted either by consolidation or by compaction. Basically, you're going to include, make inclusions to the soil using external materials like rock, concrete, better soil, by different methods. So when the soil behaves in a non-granular way, these are the most effective methods. There are various techniques. In today's presentation, I'm not going to present all the techniques because it's endless. Even in our company, we improvise with the techniques sometimes. We do combinations. So let us look into that on the methods of improvement. Basically, we are going to talk today about this consolidation, compaction, and reinforcement. Okay, let's see what are the details of these three detailed methods of these things. Consolidation. We know what is a vertical drain. Basically, the stress has to be relieved from the inside of the structure, inside of the soil, deep, either through surcharge or through self-consolidation. PVD is called prefabricated vertical drains. You draw in pipes into the soil, which gives pores and allows the pore waters to be escaped through the pores. The vacuum consolidations basically put pressure and consolidate. Then you have a mixture of stone columns and PVDs, mixture of many things. I've put only minimum things here. This is consolidation. Normally in our construction, what I've seen the past 30 years back, When you backfill here, we always make the backfill stay there for a couple of months, 3, 4, 6 months, so that it self-consolidates. Even in our building constructions, when we do the basements, when we backfill inside it, we sometimes keep it, we pour water and keep it for some time for self-consolidation. Basically, this is the principle for self-consolidation. Induced consolidation is, if the ground level is this, you fill it extra meters so that the weight of that put pressure on the soil and consolidates, and then remove the surcharge and move to the next location to give consolidation. The second, as we told before, is the compaction. Compaction has, it's an ocean. There are too many techniques for compaction. Surface compaction, you all know, using vibratory rollers rolling around to give compaction. You have shallow compaction up to 4 or 5 meters. You have semi-deep compaction up to 9-10 meters, and you have deep compaction where we have done up to 35-36 meters compaction using something called vibro compaction. I will go detail into this later. Then you have dynamic compaction, dropping hammers, basically using dynamic loads. It all depends on the soil, the type of, the grain analysis. Then you have rapid impact, which is again shallow compaction, which is deeper than the surface compaction, high energy impact compaction, and then rolling. When it comes to the expensive part of the soil improvement, it is soil improvement using reinforcement. Basically, inclusion. You're going to rigid inclusions. You're going to put rigid inclusions. This is where the costs come up. You have stone columns. You have dynamic replacement. Basically, it's a combination of dynamic compaction and stone columns, increasing the stiffness of the soil. Then you have soil cement mixing. Grouting is an ocean. It's a huge. There are different types of grouting: compaction grouting, permeation grouting, pressure grouting. Then you have something called FDC, that's called full displacement columns. This is like a pile again, displacing the soil and fill it with concrete. Then rigid inclusions, sand piles, VCC. This is variable compaction columns. Vibratory compaction columns. This is all inclusions, rigid inclusions to the surface, to the deep, to the soil from surface. Techniques. This is a typical PSD, which is particle size distribution graph, which is being taught in S7 and S8, I believe, in the foundation engineering. I don't want to go detail into the design side of it. What I'm going to say is that on the right side of the graph, that is A, this is B, C, and D. A and B can be compacted using vibrations and everything. You don't need replacements. But C and D, these are silt and clay, which needs replacement. That's where you need reinforcements, either rigid inclusions or stone columns or whatever it is. So the right side one, it can be compacted using surface compaction, vibratory compactions, deep compactions, etc. Again, same thing. And from right to left, the cost increases. When you look into the percentage of passing of the fines, on the right side, you have the percentage of fines is less. On the left side, the percentage of fines is less. This is a bit design side. I don't want to go too much into it. It's just for zone A and zone B can be used for surface and vibro compaction. Zone C and zone D, you can go for reinforcement. Basically, you're replacing the soil or compacting with a higher stiff material. Okay, when you want to do a soil improvement, first of all, you need to decide what are the performances required. You have a performance specification. Any building, any design, you have a performance. When you design a structure, you design a beam, that you always find out how much is the load to be distributed on the beam or then to the column and then down, and then to the foundation. Like that, you always look at the performance requirements. At the end of the day, as I mentioned before, you increase the stiffness of the material. Well, how increase the stiffness of the material? By increasing the angle of internal friction. So first of all, you have to find out the bearing capacity and enhance it to the required one. You find out how much is the bearing capacity of a soil at the moment and how much you have to improve based on the loads, what is coming from the structure. Then you have to limit the settlement. Sometimes certain soil are good enough to carry the loads coming in, but it might induce settle on a long-term basis. In that way, you do a settlement analysis and find out what is the capacity of the current soil for taking the load and giving a settlement in the next 25 years. So you can do a 25-year analysis by using different techniques in the design. And like that, you limit the total settlement and the differential settlement. Then the risk of liquefaction. I think this area, especially the southern part of India, is not prone to an earthquake. So we are lucky not to design too much into the for the dynamic load factor of from the earthquakes. The place where I come, it's categorized as Zone 2B. Earthquake analysis experts and structural engineering people might be knowing about this different zones of earthquakes. We come from a place called marked as Zone 2B. That requires a peak ground acceleration of 0.18. When you design a structure, be it a superstructure or a foundation or soil, without considering the liquefaction and the dynamic load factor, you will see that the requirement is very little. For example, if you need 0.6% steel for a foundation or 120 kilogram per cubic meter for a column, when you consider the dynamic loads, dynamic load factor, you will see that it might go to 1.2, 1.5% of the steel. This is why if you happen to come to UAE, you can see the steels, the columns and beams and everything, you can see very high reinforcement. People visiting our projects from overseas, they come and complain that you're using a lot of steel. When we explain to them, we understand. We are in a Zone 2B. Actually, in the last few months, they have changed it to Zone 2A, which have given us a relief in savings costs. It's Zone 2A, so the PGA is only 0.12. So mitigating the elimination of the liquefaction potential during an earthquake is the most important thing when we design the soil improvement in earthquake-prone areas. That is not the only thing. When you consider, you can only consider the liquefaction potential, but you have to consider you have to limit the settlement due to earthquake as well. So all these things, when you consider, you need to improve the soil. Okay, there are additional performance of certain areas for a structure, certain corner of the structure, the load might be a bit more. You need to improve the soil bearing capacity of that soil. Typical structural engineering one, you have to improve, for example, in an area where sometimes reclaimed areas, if you look into an area called Palm Island, you must be knowing Palm Island in Dubai. That's a completely new island, all reclaimed. All the structures are on piles, but before doing piling, they have performed soil improvement. That's only because that to reduce the negative skin friction of the soil. Because when we looked into the analysis, when we found that if you add these loads to the piles, the cost of the piles are going to be much more than the money you're going to spend for the soil improvement. So we better do the soil improvement, which is good for the whole structure and the surroundings. We did a complete sweep. We swept along and did the soil improvement, and then did the piles for the required areas. Effects of lateral spreading due to earthquakes. When earthquakes, the sand will move. Effect of lateral spreading, basically improves stiffness, friction on the pulse, then angle of internal friction. I told the same thing before. Accelerate the rate of settlement. Okay, when you improve the soil, basically you're accelerating the settlement. You said the settlement which was supposed to come in 25 years, it might come in 2 hours. So this is what we do in soil improvement. Elimination of risk, shear failure. Ultimately, when you improve the stiffness of the soil, the shear failure is reduced. Okay, now consolidation techniques. Again, let me go back to the slide where I've mentioned what are the 3 important facts of soil improvement. It's consolidation, compaction, and reinforcement. Let's come to the consolidation techniques. Vertical drains. I believe you know vertical drains. These are basically drain pipes pushed or drilled and installed through the soil. These pipes have slotted holes, which basically goes down and take the water or air out. Because in clay structure, you know, the drainage is very little. So basically they're making a drainage layer, there might be intermediate layers. If you look into the structure here, you can see the bottom layer, there's a compressible layer on top, which is soft, and it is drilled through, and you're basically allowing the stress to come to reduce by taking the water or the air out. Basically, that's where when you go for natural consolidation, this comes automatically over a period of time. Whereas when these are induced vertical drains, which is very, very familiar in parts like Jordan, Lebanon, Iraq. Iraq is the place where vertical drains are very much required because they have a clay layer on top, which disallows the water and the air to come out. So the moment you drill, you will see that air and water coming out like aquifers. And you can see, so I've been to Iraq and I've seen when they drill, the machines go down. Even before giving the, what do you call, vertical drains. These are all prefabricated verticals. We have done up to 60 meters. We have drilled up to 60 meters and did this drains. This is basically the principle of this. You know, you have a compressible layer, you have a compactable layer down, basically take the drain pipes down and then release the pressure either naturally or put the surcharge. You put the pipes and you can fill the surcharge with this load. You basically drain the soil out, drain the water and the pressure out, sorry. Install vertical drains, apply surcharge, consolidation time, remove surcharge and put the surcharge to the new place, and the method is repeated. The second technique for then we go for the compaction. Compaction is classified into 2 types, basically the surface compaction and deep compaction. Surface compaction, you have different techniques. The easiest way is the rollers, which I'm not going to talk too much about it. This is called high energy impact compaction. These are rollers. From the shape itself, you know how it is going to work. I will show a couple of videos which shows these things. Basically, these are basically rollers, triangular, 3-sided rollers, which is being rolled, and then compaction is going to basically just drive around this using this tractor, and compaction is done automatically. This is basically, this can compact up to 2.5, maximum 3 meters. These are the equipment which we fabricate, which we produce. This is where it is. You can see it. There are 3-sided and the 5-sided. 3-sided are the more powerful. You can see 25 kilojoules and 15 kilojoules. It depends on the type of soil. If you ask me which one you choose, it all depends on the type of soil. Basically, they're going to impact, and the pressure is being pressure is being transferred down, and over a period of many passes, many rolls, the bearing capacity is going to be increased, and you will see settlement as well. I saw a short video of, I'll show a short video of this HEIC. Basically, it's been driven like this. So you actually design these things based on the soil, you design based on the counters, based on these rollers, they design, they find out what is the thickness of the layer to be improved. And based on that, they will always design the type of pounder, the speed at which it can roll, and the number of passes. These are all designed. It's not that you drive haphazardly. You have a series of what you call tests to be done before and after. You do a pre-CPTs before and a post-CPTs concentration test. So this is being designed and done. This is the way it's done. So after that, what they do is they do the roller on top. This is the roller compaction for the first 50 centimeters top layers. This is basically high energy impact compaction. This is the shallowest compaction in the ground improvement, apart from the roller side. The roller is there for every type of compaction. At the end of the treatment, whatever you do a roller compaction. Now, the next method is called rapid impact compaction. This is basically using dynamic loads, dropping hammers fixed on a machine. These are the machines produced by us. You have different type of machines and different types of hammers as well. The middle sketch is very clear how the energy is being transferred down. So you do a series of hammering here, and you overlap based on the design. Again, it depends on what type of soil you're treating with, what type of method, what type of equipment you're using, and what do you call thickness you're treating. Just to show videos on this one. These are all amateur videos taken from outside, okay? This is a fixed hammer, fixed base, fixed base with a hammer hitting on this one. This is from a crane mounted. I'm just showing this to show different types of equipment. I think if I keep the speaker on, it will be. So this is based from a crane. The other one was based on an excavator mounted one. This is a smaller one. This is a bigger one. This is from a piling machine base. This is from a piling machine base. The base of the machine is the piling. The other one is an excavator. This is a huge hammer. Basically, what we do is that we drop this hammer based on the design. The number of blows has been designed. The type of hammers are designed, and we can compact up to 4 to 5 meters, on a normal soil. This is basically the rapid impact compaction. The next one, surface compaction, is a bit more deeper. This can go up to 9, 10 meters. We normally do it from 5 to 10 meters. Again, basically, this is nothing but dropping of hammers. You have a crane. It's been fixed to a hammer through this wire rope, and then it is being dropped. This is an example. I switched off the audio, okay? So this is dynamic compaction, where we use the hammers. This is also hammer. It's a bigger hammer, you can see. You lift it. This height of lift also is being designed. It's free fall. This is a hammer being designed in a different way. This is a 25-ton hammer. The weight of the hammer is 25. This is something exclusively designed for a particular project. And the thing is that we have designed it in different. You can see when it folds, it's different. It is snapped from there. And the machine, you will see it now, it goes down. It goes and picks by itself. This is basically done in Germany, where the German labors are too expensive. So they lift it again and drop it. So sometimes you drop 8 or 10 times each location for a treatment of about 8-9 meters. You can do it, and you will see huge craters in this one after dropping. I don't know whether I have shown this craters before. Look at this crater. If you see here, sorry, can't you see it? Oh, these are craters. It's coming a bit late. Yeah, probably it's coming through it. Those craters you can see. There's a man standing in the crater. This is from the treatment. So you will see a lot of craters like this, a series of craters which has to be backfilled and compacted. The principle of dynamic compaction, you can see it from the sketch. It's being compacted. You have a phase one, which is phase one, compact with a huge hammer, which will reach up. Okay, you'll do a pass one with a huge hammer, and then as you go up, you reduce the size of the hammer, all based on design. Okay, sometimes we might use the same hammer with the limited number of passes and the reduced drop height. But it's when we go for big hammers, you need a bigger crane, and the cost is very high. So always what we do is that when we do the first pass, you move to the next location, and the smaller machine comes in and do the other one. Or what you do is that you bring the RIC machine to do the top 5 meters. So you will see an overlaps here so that the whole area is compacted. This is the way it's done. That's the second pass and third pass. And the pass 3 is the surface compaction. That's a surface compaction. Now, deep compaction. What we have spoken now is that compaction from the ground surface. Now we go to the deep compaction. Let me go back again to the compaction. You have surface compaction, which can be done using high energy compaction, rapid impact compaction, and dynamic compaction. High energy compaction can be done up to 2.5 to 3 meters. Rapid impact compaction can be done up to 4 to 5 meters, and dynamic compaction can be done up to 9-10 meters. Now, beyond that, the energy, when you drop a hammer, the energy will not be transferred beyond that. So what we do is that we go for deep compaction. Deep compaction is done by using vibratory techniques. You have a vibrator which is being poked into the ground and vibrate it, so it horizontally displaces the soil, and when it compacts horizontally, the ground will come down. The equipment what's been used are the vibrators, the cranes, then you have the power pack which will vibrate it, generators, which different types of generators, then you have pumps also. What we normally do is that when you do vibro compaction, you mix air and water through the nozzles of this vibrator so that it vibrates. It won't be having choking of the moving parts. Basically, compaction, this is deep compaction. The vibrator is this machine which is being driven down for penetration. It penetrates to the required depth. Then basically we install it, which means that we hold it we penetrate to the maximum depth and hold it at different steps so that the soil around is compacted. As you compact down, you will see the ground settling down. So you can see even the crane, which is being, used for compaction, settle down sometimes 10, 15 centimeters each location. At the end of the day, when you finish an area where you compact about 15, 20 meters, 10% settlement you normally get. If you compact 20 meters, you might see 2 meters. So for doing this, if you want a final grade level of this, let's say this is 0.00, you fill based on the compaction requirements, you do extra fill, so that when you compact, you reach that figure, reach that level. This is the installation, and then this is completion of it. You lift the compactor, it lifts the vibrator at different levels, stay there, keep it there for some time, retain it there for some time with vibration. These are all based on designs, because it all defines, it all defines the design report clearly tells you how many times you have to stop in between and what levels you have to stop. That's based on the type of soil you interfere. This is the deep, you can see the soil settled, these are all vibro compacted areas. Actually, I looked into a video, I did not get it. I was thinking that I had this video. When I looked at it, I didn't get it. Honestly, I prepared this presentation only a few days back. Anyway, now we come to reinforcement. Again, let me go back again. The three techniques are consolidation, compaction, and the reinforcement. We completed the consolidation, we completed compaction, and now it comes the reinforcement. This is the most expensive solution for ground improvement, most expensive solution. And this is where we are specialized with worldwide, because the other ones are a bit cheap. We make machines and give it and sell it to many companies. But we are specialized in this one as well as this deep compaction. Although we have all other equipment to do the works, because that might be part of this project. Sometimes we do this together as well. Okay, reinforcement. When we talk about reinforcement, it can be anything. How do you, see, whatever you do on the soil, it can be reinforcement. When in olden days, when we backfill our basement, we use hand equipment to compact. So basically, you bring in good material to mix it with the bad material and to make it a better material. At the end of the day, you're increasing the stiffness modulus of the material by increasing the Young's modulus and the angle of internal friction. Everything is E and phi, nothing else. In soil improvement, it's only E and phi dash. The equipment used is more or less the same equipment being used for the deep compaction. Basically, you're poking it down, and those holes, when you do vibro compaction, you're not filling it with that. Whereas in this one, we are going to fill it with inclusions, either cement, concrete, sand, whatever it is. There is one more method which I have not specified here in the reinforcement. There's something called dynamic replacement. Dynamic replacement is, I have explained about the dynamic compaction dropping hammers. So what we normally do is that if you have 9 drops to be done, after the 5 drops, we'll be filling rock into this. So we push the rock into the sand. So it is a combination of stone column. It's a little bit more cheaper. So we do many methods in between. I just want to tell you that there are many methods in between, a combination of these things. But I'm only talking about the basic techniques here. Equipment used again, power pack, the vibro hammer, the cranes, generators, and the pressure pump. There are 2 types of stone columns. Let us talk about stone columns. 2 types. Stone columns again are, you're going to, using this equipment, you're putting the vibrator down and then fill with rock. The rock can be, use the same equipment, but the rock can be filled in different ways. The first one is, it's called dry bottom feed. In some places, some clients, especially underwater, you don't want to put the rock onto the seabed. I'm away from this. When we go to the seabed, you have to improve the seabed. How do you improve the seabed? You pull the poker down. If you put the rock from a barge, it will be spread, and you're not sure all the rock is going into the holes. So what we have done is that there's something called dry bottom feed. Bottom feed means there's a tube going through the center of the vibrohammer. So we feed rock from top, it goes down, the valve is closed down as you go down. Once it reaches the bottom required depth, we're filling rock through the hoppers, and it goes down through the stem of the auger, goes down, and the valve is open, and slowly we pull the vibrohammer up. The normal method is wet top feed. This is going to be very wet areas top feed. You put the vibrohammer down and feed with the wheel loaders or the shovels or wheel loaders, rock inside to go into the craters. So the stone columns, when you talk about it, using vibrohammer, dry bottom feed, it predominantly in underwater structures. Some areas we don't want to disturb the topsoil, they do dry bottom, but this has limitations in depths and all, because if it goes beyond 10-12 meters, you have an issue with the equipment. You need huge equipment, which is going to be expensive. So most 90% of the stone columns are being done using wet top feed. This is the method of installation, penetration again, installation of stones, completion. You can, on the right picture bottom, you can see a bulge on this. That's the type of soil. In that area, soil is more compressible, and hence the stone size has gone up. So stone columns, you might not get a pillar type structure when you do stone columns. Depending on the type of soil, the stone will go laterally. This is the bottom feed. You have a hopper which is there on top, fixed on the top of the. Here you can see on top of this a hopper. You fill in with this one and take the hopper up, and then through the stem of the auger it goes down to the bottom level, and then it's being lifted. This is the method for the top feed columns. You just vibrate it down, penetrate it down, then you replace by using stone, dropping stones into it by using a wheel loader, then filling it and coming back. You can see on the right side the rig setup, how it's been done. You have a shovel which is feeding the vibrator with the stones, and you can see number of columns being done there. Next is reinforcement method is rigid inclusions. As I told before in my initial talk, a pile can be a rigid inclusion. Okay, at the same time, it's taking a vertical load as well. These stone columns can take vertical loads. The only thing is that the difference between stone columns and piles can take vertical loads. It's not vertical loads, tension loads. Whereas stone columns cannot take tension loads. That's why when you design warehouses, low-rise structures, tanks, foundations, you will see stone columns. And whereas high-rise structures, when you have bending moment on the piles and tension load on the piles, you go for deep piles with the reinforcement. This is called full displacement piles. These are different types of augers where you can see the auger is displacing this as you drill in. The auger is displacing the soil towards sidewise and then pumping concrete onto it. There is another method called CFA, continuous flight auger, which I have not mentioned here. There are multiple items. When we look into our product profile, we have so many. So I only have taken the most common ones because it's an ocean. We have too many equipment, too many types. This is basically displacing the soil. You can see the arrows where it's displaced. And at the end of drilling, you pump concrete and withdraw the auger, and thereby increasing the stiffness of the soil. This basically, you don't see any spoil coming out. Nothing will come. In stone columns, you will see bad soils come out, especially silty soil comes out when you put rock inside. Whereas in this one, nothing comes. The ground will be clear. You just go there, drill it down. You know, the soil is displaced to the side. Drill it down and pump concrete or sand or cement or bentonite, whatever, a better substance through the stem of the auger and displace it. Basically, this is very good in shallow one. If it's very deep, you can't do it. This is basically shallow, around 12, 13, 14 meters. If it's go for 50, 60 meters, you have to go for piles only. This is called mix in place wall. Mix in MIP. This is, you have single auger and multiple auger. This is a patented product by Bauer. You have multiple augers on a drilling head. So this mix the soil itself. You know, you add cement to it. So you mix the soil and increase the stiffness around. It's called mixed in place. We do it mostly for cut of walls and all, where you don't want soil ingression or water ingression to the other place. Especially we do it in contaminated places where the contamination is not being spread to the adjacent place. This is called mixing. This is a kind of soil improvement. You have single auger here and multiple auger. These are multiple means 3 augers, not more than 3. So these augers basically rotate counterclockwise so that it mixes the soil. And this can be sometimes reinforced also. You can see a reinforcement here coming to this. I've given an example there so that, you know, some areas you mix it with, you create a grout column or a grout structure and push the reinforcement into it. Again, let me come to the summary. Soil improvement. As I've told before, it is consolidation, compaction, and reinforcement. Consolidation, we have explained many types of consolidation techniques: surcharge, induced surcharge, natural surcharge, combination of sometimes stone columns, sometimes vibro compaction. Vibro compaction is mostly used, especially when you often do drainage along with vibro compaction. When you vibrate and if you have a drainage, the soil compacts so quick. Then you have compaction. Compaction includes surface compaction and deep compaction. In surface compaction, you have rollers. Then you have high energy impact compaction. Then you have rapid impact compaction, and then dynamic compaction. This goes from surface compaction 0 to 1 meter, rapid impact compaction 1 to 3 meters, HEIC, which is high energy impact compaction 3 to 5 meters, and beyond that 5 to 10 meters, it's been done using dynamic compaction. If you ask me, can't you do stone columns for these? Yes, you can. It all depends on the soil. Some areas you can't do these surface compactions. You have to go for replacement. This is basically in areas where you can't do compaction. So these are the methods for compaction. Then comes the reinforcement. Reinforcement is a vast topic. I have only presented here only the most common methods, which is stone columns, dynamic replacement, full displacement piles, vibro compaction columns. As I mentioned before, the most expensive method of treatment is definitely reinforcement, because you have to bring in external materials, whereas the other methods which I've mentioned for compaction, consolidation, you don't need external materials. Even the surcharge which is being used for consolidation can be reused. You know, surcharge is basically you're putting additional pressure, nothing else. So that's basically end of my presentation, and it's open for discussion and QA. I think I stuck with my time. Any questions you can ask? I can give my email address also. If you can ask, you can do that. Actually, I forgot to put my email address here.
Now the session is open for discussion.
I suggest ask them to raise their hand. They can raise hand option is there, no? They raise their hand, they can unmute them and then ask questions.
Sir, can I ask a question?
Yeah, please.
So we have many transportation PG students here. So
Transportation.
PG students.
We have transportation here now?
Yes, yes.
Okay,
We have a
good.
PG, yeah, MTech in transportation engineering. So can you just enlist the kind of soil improvement measures from your experience that has been done for pavements?
For
pavements.
pavements,
Yeah.
okay. Basically, what type of pavements? Is it vehicular movement or?
Vehicular movement.
Okay. For embankments, we have done a lot of soil grid walls. I have not mentioned these things here because there are so many things and it's too vast. We did geogrid. I think the transportation people know what is geogrid structures. We have done that, and we have done a lot of stone columns for transportation, especially for approach roads, stone columns to avoid piles and all. We did stone columns. And we did retaining walls, a lot of retaining walls, and in between we did, the thing is that the approach walls here is only probably 20 meters. What we see there is 70, 80 meters approach roads, it's a 5-lane roads, each side 10 lanes. No, it's 70, 80 meters, including the right of way. So what we do is that we build the retaining walls on the either side of the road, and in between you do stone column, a grid of stone columns. It all depends on the type of soil you fill and the height of embankments. The axle loads there are a bit higher than what we see here. So we do stone columns mostly. And these stone columns vary from 6 to 10 meters, 6, 10, 12 meters. Geogrid is something which is very common in the Gulf as well. I believe geogrid is common here as well, right? I've seen some geogrids in Delhi when I was there. In 2018, I've gone to a site.
Sir, just another doubt also, like I was previously, some 18 years back, I was in Abu Dhabi. So in those times, we never had many rains or anything. But recent times, like what we hear is even places in the Middle East are also subjected to heavy rains,
Yes,
right?
yes.
So what kind of new challenges have you had to face in these ground improvement measures due to the changing climatic scenario in those areas?
Okay, the rains in the Gulf doesn't affect the soil there. Why? Because after 2 meters, there is water everywhere. Most of the places, most of the cities around. I'm not talking about Alain or the mountain areas. So after 2 meters, it's already saturated. Unlike our place here, our place is the place where you need soil improvements. But luckily, we have good soil here. Okay, our soil here is fantastic. When I talk about the problem, what we face is that when we do backfilling here, no proper compaction is done. Wherever I go, I have a problem. Whether it's my construction, when I go for sometimes we have external services with biotech external investigations. When I travel, I see in India, what I've seen is that they don't do proper backfilling. It can be surface compaction, because when you do a 2-meter fill, you don't need any special ground improvement. You have to fill in every 15 centimeters. But they relaxed the specification to make it 30. After 5 years, you see settlement. Payments is put, you can see undulations. This is the reason. There is an international specification, and there is a reason why they say these things. The rollers cannot transfer the energy beyond 50. The small rollers cannot transfer energy beyond 15 centimeters. So you cannot, cut the corner and try to save cost for one layer of compaction, which costs very little money. And after 5 years, if you want to change the entire paving, it will be 200 times. So water doesn't affect, provided that the top 2 meters is properly compacted. So, okay, apart from the drainage, I don't want to talk about drainage requirement for soil mechanics side. The rain doesn't affect much, to be very honest, in Gulf. Whereas here it affects, yes. But here, you know, all the natural fills are all consolidated. So you not see further settlement.
Thank you, sir. So we have many of our alumni logged in through the online platform. I can find Mr. Shaji Philip from Singapore alumni. So hope he's also having some questions. You can interact, and also any of you who are logged in online can unmute yourself. Just please raise your hand and unmute yourself and please ask questions.
I think Sujata also must be there from Singapore. Sujata there?
Yeah, Shaji is there right now. I think Sujata Manoj has moved to Australia. I don't know whether she is there online.
Yeah, Sujata Manoj is my classmate. She moved to Sydney now. She's in charge of the geotechnical division in the Sydney Metro.
Yeah. You can ask about metro also. I've done a lot of metro constructions. Okay.
Yeah. Actually, I mean, it is a very valuable presentation. I was going through all the steps of the soil improvement projects. I mean, from Reji John. It's quite very valuable. I really enjoyed the presentation, and it is. And what I can share is that along the vehicular and all the sort of soil stabilization. Actually, there's a couple of methods. I mean, shotcreting is also part of soil improvement methods, right? Shotcreting.
Shotcreting is surface treatment, basically.
Yeah.
Then microfining. But soil nailing is, yes. Soil nailing is definitely, you know, soil nailing, anchoring. There are so many methods. You know, I've just brought only the simple ones. Soil nailing, anchoring, grouting. Grouting is a subject which is very, very vast for soil improvement. We are doing a massive project underneath the Abu Dhabi airport now. It's a massive project. Thousands of cubic meters of grouts, you know, being pumped. And that too, special grouting. It's called microfine cement grouting, which is not available in any part of the world. We bring in cement, this cement, especially from Germany. It's microfine. You know, the diameters of the cement material is very, very fine. I mean, it's not commonly used because it needs very special care to handle because it's very fine. It's dangerous also.
Yeah,
so we are doing the grouting at the moment. The grouting is a very important division of soil improvement, which I have not spaced because that itself is a huge topic.
Yeah, exactly. We seen it in a part of metro tunneling projects. We've seen it here. Earth stabilization and the micro piling and shotcreting methods. We saw it over here also. I mean, it's very, very useful information. Then as part of when I was in Kongan, where the soil was very unstable, especially the tunnel portals, there also it was not shotcreting, but there was different methods of soil stabilization were there. When we are using slabs to temporarily protect the soil from collapsing, then we'll do the head and bench system for the tunneling. So I mean, also learned very early in my life. I mean, at the time I didn't understand much about that. Then later I could get a deeper knowledge of that. Yeah. Thank you, Reji.
Actually, when you talk about tunneling, you know, that itself is a huge subject. I cannot even. There's something called ground freezing. You know, you must be knowing very well. The ground freezing is done when you do a horizontal tunnel. While you drill, you make sure that you know the ground doesn't collapse. So what we do is that around the tunnel, we do horizontal drilling and inject chemicals or grout or whatever to freeze around so that enables us to drill. That's called ground freezing. That's horizontal drilling, basically. That we commonly use, especially for the pedestrian tunnels in Abu Dhabi. You must be knowing across the Corniche, we did the ground freezing everywhere. You know, this itself is a huge topic. I don't want to say all these things, you know. That's why I told a basic introduction. It's not introduction, it's basic introduction.
So we have a question in the chat.
Then I also seen a couple of type of other soil improvement that micropiling with wooden, like cow piling and bamboo piling for drainage systems, especially soil like peat and clay, some types of clay.
Yeah.
Thank you, sir. We have a
Thank
question.
you.
We have a question. How to ensure the required strength achieved by the GI method adopted? Any special methods available? This question is-
Definitely, we as contractors will be murdered if you don't achieve. So there is something called penetration test. So we have CPT equipment. What we do is that before doing anything, we do something called pre-CPT. So we go to the ground, we drive the machine, and we drill through, do a penetration, and take a CPTs at different levels. We look into the ground level and find out from what level we need the treatment. And based on the pre-CPT results only, we design the soil improvement. And after doing that, we do something called post-CPT. After post-CPTs, we do zone load test. We have plate load test and zone load test. CPT is something which gives the Q values. Definitely, without which we cannot get paid. This is the requirement. These are all performance requirements. They will tell you have to achieve this much Q value. So we do pre-CPTs, and they have intervals every 60 square meters, one CPT, every 100 square meters. It all depends on specifications. Even sometimes we do more because we as Bauer, we make sure that the areas where we are compacted is good enough to take the load.
Sir, I have a question. So
Yeah.
we have seen a lot of calamities during the 2018 flood, especially in the terrains, hilly terrains. We have seen
Yes.
buildings collapse there. So can you suggest some methods? Can we go for construction with soil improvement techniques there, or is it completely we have to avoid construction in the hilly terrains, as Gargill Commission all have said?
Okay, for that, let me tell you. You know what's the best soil improvement? Planting trees. There is nothing better than slope treatment other than planting trees. When you cut trees, you will see what has happened. There's nothing but because the roots are anchors, basically. The roots of the trees are soil nails. There's nothing better than that. If you go to see, I live in a place called Pathanamthitta because my house is next to the bank. We have trees there. We have no issues for our banks because our property is banks. We don't cut trees. Although even if we cut trees, we don't cut it fully, we trim it. We have no issues. We have seen people who have cut in front of our property and below our property. We have seen it being damaged. So the best thing is other than that, you have soil nailing. You can do soil nailing, definitely. If you go to Europe, all the slopes, if you go to highways in Europe, I know at least some of the people must have driven through Europe. I have a habit of driving. So when I go to Europe, I take cars and drive around. Every slope they maintain. Either they plant trees or they do soil nailing, especially on highways. Even with that, sometimes you see failures because you will see soil failures. Because when you see active soil failures, this is being basically treated by using soil nails. If you don't do soil nails in a permanent treatment, nothing better than trees. And do trees which generates longer roots. There are certain trees which makes longer roots than short roots.
So any more questions? Somebody who is in online, please can unmute yourself.
I have some of my classmates joined. I can see.
Hi, hello.
Yes, please.
Hi, Reji. Good morning.
Hi.
This is Sakir.
How are you?
Sakir, this is Sakir, Reji.
Yeah. I can see you, man.
All right. Okay. Anyway, I'm driving, Reji. I'm unable to. I couldn't see this presentation fully, but I joined very late. Okay. I have a few questions, but I'm not prepared to ask for such a detailed engineering detailing, because even I come across with many kind of soil improvement where I believe in one of my project in Sharjah, where I think we have done some stone columns, but I am not aware of such details. But I need to ask, I need to understand in a detailed way. I will sit with you later. Anyway, thank you so much. I like your presentation, and it is wonderful presentation. I hope you will come out with many more such presentations later. Also, I would like to know, Reji, about the commercial aspects actually. Okay, especially in Kerala, where kind of stone columns and what is the commercial aspect? Okay, I mean the price. Okay, also locations compared to our soil conditions. You said in Kerala our soil conditions are excellent. Okay, so do you see any kind of soil, stone columns like in the paving, as one of somebody asked in the beginning? Somebody asked about the soil in the pavement area where the stone columns are. How it is possible? Okay, one more question. Where already the pavement is laid, okay, how we can improve where the settlement is already taken place? Can we go for some kind of modification or improvement method? Can you suggest something on that which is already done, executed, please?
The first question is that you talked about stone columns possibilities in India, in Kerala. Look, what I've noticed is that in Kerala, all the places where we have good soil, good sand, the building has come up. Now we are going into places where the soil is weak, especially along the coastal areas where you have clays and silt. You definitely need soil improvement if you want to do something properly. Okay. Most of the places what I've seen is that you go for foundations, deep foundations, piles or whatever it is, and you ignore the surroundings. This is what that's the first picture I've see. It came across my mind. That's why I chose those pictures. Okay, yes, there are definitely requirement of stone columns. Many piles can be avoided if you do stone columns. We sometimes all the time, especially if you go up to 6-7 story structures, and if it's the footprint is big, you definitely don't need piles. You can go for
this is what I want to know actually, where we can.
I've been in the. Sorry, go ahead, Sakir.
No, this is what I want to know, where see very expensive methods like CFA piling and all, like which can be replaced with the stone columns with a cheaper method, because of course the Kerala or Indian market is always the price sensitive market. You know that this is for contractors or the people who are investing on the buildings, where if they can save, because we don't know. See, people are driven by, or people, they see the engineers or the specialists who advise, okay, on the conventional type of piles, okay, where this heavy cost is there. Okay, where can we cut the cost and go ahead with some sort of cheaper methods?
Look,
please.
It all depends what you want, what quality you need. It all depends. Definitely there are many methods where we can cheat, but there's a limit where you can cut. If you want to do certain things properly, you might need to have some cost on the one. The second question which you asked is basically what we can do on pavings which has been already executed.
Which is settled.
On the pavement, I don't think you can do much. On buildings, yes, probably you can do underpinning or something like that. On payments, better you remove the payments and redo it. I'm not sure you can do it, because we at the moment what we are doing in the Abu Dhabi airport is basically rectification works. In 2012, when they designed this Abu Dhabi airport, I think Dr. Amal knows about this new terminal which is coming in Abu Dhabi airport. I did the foundations of the piles, foundations of the buildings, which is about $150 million. No, about $180 million project, massive projects. We have about 20 drilling rigs working day and night. You know, we were pouring concrete, about 4,000 cubic meters of concrete every day. Okay, 2 concrete plants. It's a massive project. 1.5 meter diameter piles down to 70 meters. And the area was full of cavities and is full of cavities. A pile which was supposed to take 70 cubic meters took up to 700 cubic meters, and then we had to abandon the pile because the concrete was flowing and never stopping. But we got paid every cubic meter. Okay, that was a contract. At that time, we have told technically, we have studied the complete area, and we told them, when you do the infrastructure, the infrastructure was not in our scope. Our scope was only doing the foundations and retaining walls. We told them, you have to improve the soil, otherwise you're going to pay a lot of money. The problem now is that they put all the peripheral, all the services, which includes manholes, sewerage pipes. After 3 years, they started seeing manholes settling, the connections are broken. Now they called us, last year they called us to give a proposal to do rectification works. We have to rectify from that person. They don't want the manhole to settle further. So what we are going to do is we are drilling underneath the manholes and grouting, which is an expensive affair. Whereas we drilled earlier on a grid and pumped, the grout inside was much cheaper. Now they are paying about 5 times the cost. This is what we are doing at the moment. Since the last 1.5 years, we are doing it. It's a massive contract and a problematic contract because you have structures around, you have limitations, you can drill, you have no headroom. Our machines had to be cut cut to half to make the headroom less. Expensive project. This is what, when you pay penny, this is what you do. So, Sakir, your question, I want to ask you, I want to reply you. Once the payment is done, it's better to remove the payment temporarily, compact properly, and redo it again. I don't think you can do it. Unless you want a portion of it, you can do some chemical injection or something, which is an expensive affair. I hope my answer is clear, Sakir. He's my classmate, okay? My batchmate, my benchmate. And he's in Abu Dhabi.
Okay, thank you. Thank you very much, sirs. Is there any other question from the audience or somebody who is there in the online?
Are there any students here? Can you raise your hand? Students?
Sir, just one more question, sir. Usually ground improvement is like a widely researched and discussed topic all around the world. So people are trying out new methods based on their experience.
Sorry, I missed that.
People are trying out new methods and maybe some new improvements to the existing ones. So in whatever we study in geotechnical engineering, we also learn about how monitoring is important, equally important once the ground improvement measure is done.
Yes.
So what the scenario we see around here, especially in Kerala or in India, is that we do some improvement and we just leave it and go. We perhaps do not monitor its performance later on. So can you give your experience, especially with respect to the Middle East, so where these things are more meticulously planned and done over a set of years' time, even after the construction?
Excellent question. This is something which I expected actually. This is very, very important. There is something called, settlement monitoring. We have settlement monitoring system by using data monitoring system. Basically, we put telltales, we put settlement markers, and it's being monitored automatically, and it's being sent to the server central station. So we have certain projects, we have contracts where we have to monitor for 6 months. This is vibration monitoring, settlement monitoring, and telltale monitoring. This is being basically we put strain gauges sometimes we plant in strain gauges to the sand, whether seeing when a bearing capacity, when a structure is being built, we monitor whether the structure is inducing more load or less load. So we use telltales and settlement markers. This is what you do. Yes, that's a good question. It's being done in the Middle East in certain projects. When we have civilized clients, this is what they do. Especially if you look into the US Embassy in America, in Abu Dhabi, they asked us to monitor for 1.5 years. But the data were not given to us. They took the data all themselves to solve secure data. Good question. I like it.
Thank you, sir.
Any other questions?
Good morning, Reji. Hello. Hello.
Yes, we can hear you.
Good morning, Raji. I am Samad, your batchmate.
Hello.
Hello, you're hearing?
Yes, partly.
Hello.
Can you write the question in the chat box?
Hello. Hello, Raji.
Hi, Samad.
Yes. Then I am actually you discussed about the presentation was good regarding that consolidation and other things. I have that one doubt because we had that in a number of tunnels because most are in that soil tunnels. No, actually in after
Samad, can you
25 years.
switch on your video also? Hi, Samad. He's also my classmate. Okay.
Yes. Okay. Because actually we had that so many soil tunnels because after about 25 years 30 years because actually in soil tunnels then we had that weep holes from weep holes
Samad, you're not
again.
clear. It'll be great if you can put in the chat box.
Okay.
In the meantime, if you have any questions here. Do we have soil mechanics masters here? No geotech. Actually, the funniest part is that I joined geotech in CET. After 1 month, I studied there. I came to structural here. Then I went back to work in geotech.
So we have our principal, Dr. Tyler here. Welcome, sir. We just are we are winding up the session. We're towards the end of the session.
Is Samad putting in any questions?
Is there any other question meanwhile from the audience here?
Any questions? That doesn't matter. Any questions on my experience like diaphragm walls, shoring walls, key walls, block key walls, breakwaters, slipways?
The question is, how can we improve soil tunnels from Mr. M.S. Samath?
Yeah, I think I mentioned about this. You can do ground freezing around the tunnel structure. You can do ground freezing and then improve the soil. The ground freezing can be done either using chemical injections or grouting. It all depends on the type of soil we have. And once the ground is exposed, you can do soil layering as well. This is what mostly what we do is ground freezing. But it's an expensive affair. But if the soil is too weak, especially if it's shallow, we do ground freezing so that there won't be any collapse while we excavate or drill. Yeah, on top hill, I think Samad, I think you can do ground freezing. It can be done through what do you call vertical drilling or horizontal drilling or inclined drilling. Anyway, basically you're improving the soil around the tunnel structure. Do you want to improve the foundation of the railway line or the tunnel structure? Foundation of the railway line can be improved by using either stone columns or by what do you call rigid inclusions. Rigid inclusions you can do like FDC or VCC or whatever it is, what I've mentioned before.
Okay.
V-pole blocks, V-pole is for the structure basically. That's why when you do ground freezing, you keep V-poles also for the water to dissipate.
Already V-poles are there, but now the one we are injecting through V-holes.
Sorry, you can inject through weep holes. You keep the holes as
We
well.
inject
Yes.
weep
The
holes.
weep holes are
but-
basically multi-usable weep
Oh,
holes.
Okay, through weep holes we are injecting, but accordingly, some locations that weep holes, other weep holes are blocking. So automatically, total that water pressure is coming on that tunnel.
You might need to do new weep holes because after some times, after some seepage, the holes, the channel will be closed. So you might need to do new weep holes by drilling.
That now
Okay, so
there
thank
is
you very
no
much. I think we
okay.
can wind up the session because it's
Okay,
time.
bye.
Yeah, it's time up. Thank you. Thank you so much.
Okay, so I
Thanks.
request our beloved
Oh, thanks, Reji.
principal to please come forward and to have a few words and also to give a memento to our beloved chief guest.
हमको दुनिया भर का दूसरा काम कुछ CSO दे रहे अभी हम CSO दुनिया भर का काम दे रहे CSO क्या बोल रहे you people are there for SWR why you are going for that SWR हम क्या बता सकते CSO ये तो दूसरा काम भी है वो अभी क्या अंगोला का क्या है एक्चुअली तो अंगोला में कुछ चेंजेस नहीं था ना
Let me formally request.
Anyway, let me say thank you once again. It's a privilege for me to stand
ठीक है
in front
5 मिनट के बाद
of
मिलने
you.
दो
I did my seminars all in that hall. You know, my MTech seminars and my PTech seminars. I still remember the subjects and the topics and the questions being asked also. Thank you so much.
So I invite Professor Amal Asad to formally give away the vote of thanks.
Respected Chief Guest, Sri Reji John, 1988 batch civil, our beloved Principal Dr. T. A. Shahul Hamid, beloved HOD Dr. S. Bindu, Global Alumni Coordinator Dr. Sudhir, all faculty, Dr. Sajib, sir, all the faculty here who are present, also all staff and all my colleagues present here, also the students from various semesters who have joined here in the offline mode, and all the esteemed alumni and audience who have joined us in the online mode. Thanking all your immense participation, let me move on to my duty of proposing the vote of thanks. We've had a wonderful session, sir. We are really honored to have you here, to have all the experiences that you have had over the past 30 plus years in the field of design and ground engineering. In fact, your presentation, you have kept it to a basic level, and you have also mentioned that this is maybe perhaps first in your series of lectures, wherein you just begin with the basics of ground improvement. In fact, it was very simple and clear to the point, I must say, as far as ground improvement measures on granular soils were concerned. That is why this talk has been made possible today, and especially it coincided with the day we have reopened as a college, bringing in all the faculty and students together. Thank you so much, sir. Let me thank our principal, Dr. T. A. Shawal Hamid, for all the support and motivation that he has provided, and for granting permission, especially in this COVID scenario where strictly protocols have to be followed, and for conducting this meeting in a hybrid mode as well. I thank you wholeheartedly, sir. I am extremely thankful to our HOD, Dr. S. Bindu, for all the support and guidance and the constant monitoring that she was doing in order to ensure that this program was successfully being conducted. I thank you, ma'am, for your consistent encouragement and motivation. Thank you, ma'am. I'm extremely thankful to my co-coordinator, our global alumni coordinator, Dr. A. Sudhir. In spite of being physically unwell for the past 2 weeks, he has made it for the event today, and he has done everything in his capacity to provide support for this particular function. Thank you, sir. I'm extremely thankful to Dr. Sajib, sir, for the guidance, motivation, and support that he has provided for this entire talk. In fact, we were really not clear until a few days back whether this talk would be possible or not. So I must say that it is the support that was offered in the department that made this program a success and a reality today. Thank you, sir. Then, of course, all my co-faculty here, the excellent team of faculty members who have provided your support in physical presence, and also the students here who have come here, and all the alumni and the students who have joined in the online mode. I'm extremely thankful for your presence here and for the wonderful interaction that we had here, the lively conversations that we had here. I thank you all for making this event a huge success. Lastly, once again, I would reiterate my special gratitude to the excellent team, the technical team who has supported Atul, Kannan sir, then Krishna Kumar sir, Reji. I'm sorry if I have missed out anyone, Tausif, Bushra. I'm really sorry if I have missed out anyone, but there are a lot of people who are working here behind the scene to make this meeting, which is in a hybrid mode. So it's actually difficult to conduct this both physically, on an offline mode as well as on an online mode, and yet get everything perfectly done. So hats off to you guys for this excellent support that you have provided. I thank you all again for your presence for this meeting. Hope this is just one of the first in this series of talks, and we are yet to have more talks. I thank you all once again. Thank you all. Tea is arranged outside. Please have it. Thank you all.